And okay, there we are. Introduction. So just sort of quickly to summarize the course. I put this picture up in the start, and my guess is that this is basically what database systems look like at the start. You knew a little bit about how to design databases and then how to use them, right? And actually put these questions to you in the first class. Why bother with tuning? What's a large database? What does the DBMS do for us? And we had some answers to that, but I think now, right, why bother with tuning, for example? You should be able to answer this question. If you looked at the project 3, then you can see a huge difference between what you started with and what you ended with, for example. So that's why you bother with tuning. What's a large database? Probably what you worked with here was a couple of orders of magnitude bigger than what you had done before, I said, from people working in the industry. But even that, we still have several orders of magnitude to go before really going into what we would call large scale. You probably got a feeling for this also in the last, when we were talking about the papers, talking about sort of the new architectures that are really designed for scale, right? And you sort of get a feeling for that is really important. And then we talked about what the database management system does for us, and transactions, recovery, things like this, and then we should have a pretty good handle on this. So what we know now is basically this. It should be a picture that you have in your mind of a database system. Be a great exam question to ask people to draw this picture. Could you do it? Oh, it's hard. I usually miss one piece somewhere, so it's okay. But to get a general picture, I mean, if you think about, for example, this part with the queries, if you take a query, what do you have to do with it? You have to parse it to get it into some internal format. You have to optimize it to get it right. You have to execute it, and then that's split into two parts. But if you think about what's happening, then you really can get a good picture. What do you do with transactions? Well, you need locking for isolation, you need logging for recovery. So put these two parts in there, and you have a pretty decent picture. So even just with just thinking about what happens with these components, you should be able to draw a rough picture that would look roughly like this. Maybe not exactly. So this was the overview of the course. So we had basically 6 weeks of algorithms, 3 weeks of tuning, and 3 weeks of new developments. And I think that it's roughly what happened. You also had some guest lectures, I think, in the last maybe 4 or 5 weeks that had to do with the tuning and some to do with the new developments. I was going to show up here, but I never had the time, so sorry. We had assignments, so we're missing the 12th assignment, right? So you basically just get the 1% for free. So still the two worst are dropped off. So then we had the project. I was a little disappointed to hear that many people chose not to return the database tuning project. I'll get to this because it's really the pièce de résistance of the course. It's really what you are here to learn. And so, and then we had the presentation. From what I understand, that went pretty well. And then we had the exams. So most of you took actually the midterm exam. I had an unusually good turnout for that. That was good. I hope it helped you to focus your learning a little bit. And then we have the final examination now on Monday. And that's again 40%, 60% if you missed the midterm, or if you scored better on the midterm than you will do on the final. No, sorry, vice versa. If you score better on the final than you will do and than you did on the midterm, then it's 60%. Sorry. But this basically covers the whole course, and I'll go through the format of this later on. And you need to pass the exam to pass the course. No matter if you had 10 across all the projects, fail the exam, you fail the course. So it's a general rule. Now, I like to look at the learning outcomes, and actually I think before starting to prepare for the exam, you should read them. in your own time and just look at, how comfortable do you feel with them. We describe the architecture, and again, you don't necessarily have to draw the picture, but that's basically what we're doing. Functionality of the major components. What are the major components? Query processor, query optimizer, transaction manager, log manager, recovery manager. So what do they do? Well, that's the kind of thing you should be able to talk about. Describe the impact of traditional computer and systems architecture on the architecture and performance of database systems. How do you feel about this? Does the wording make you uncomfortable? So what is the traditional computer and systems architecture? Main memory, processor, CPU caching, hard drive, buses between, bottlenecks, moving things to and from disk, etc. Right? How does this impact us? Well, we had the buffer manager, right? Sometimes that one gets into trouble. We have to deal with the fact that things are in memory for processing, but they stay on disk for durability, and so that gets into trouble. And so that's the recovery part. See? So if you just think about this, then you should have a pretty clear picture of this. It's just something that you actually need to think about. What is a traditional architecture? And you just get used to computers, right? It's a computer. But the way it's designed does impact the way you have to do things. I don't know how much we talked about solid state disks, but they changed this a little bit because they're kind of an intermediate layer between hard disk and memory. So some design decisions that were made for hard disks are no longer valid. And so there's probably some of these main memory databases, for example. I don't know if Hervik came here and talked about solid state disks at all. Maybe not much. Okay. So Hervik mentioned that they use solid state disks, but nothing more than that. But as it turns out, it really changes the implementation of his index, whether they use solid state disks or not. Because basically they need a lot of small random reads. And with hard disks, they are impossible. So there's a lot of buffering and things going on to avoid it. With solid state disks, it's okay. So it really changes the architecture. All right, so discuss the development of database systems and the impact of that development on the future architecture of software systems. So that sort of is something that you should have gotten from the papers. The development, what's going on, things are going into main memory. How does that change? Well, you need larger memories, you need kind of distribution, you need to, but you still need to have disks so that some things are stable. Or alternatively, if you were able to develop stable main memory that doesn't die when you turn it off, that would be great. Then that would solve a lot of things. So, of course, it's hard to predict the future, right? Or I don't know, what to say. It's hard to make predictions, especially of the future. and so it's hard to tell what happens. Okay, skills, trace the operation of the major algorithms. Yeah. Okay. That's a good question. So the question is, I've been teaching this course for a long time. That one is true. I taught this first in 2001. Has this future part changed a lot? I would have to say yes, because until 2011, maybe it actually didn't exist. So we just focused on we actually introduced this, along with Grímur, we introduced this, I think, in 2011, or maybe 2013 even. Because before 2010, it wasn't that, there was a lot going on, but it wasn't as visible. And it wasn't as, it wasn't starting to have the same impact as it is having now. And so, basically, around 2010, I realized that we'd have to do this. And so I think it actually started in 2013. I think you're right. So this is new. I did have another course that was doing, I called it Advanced Database Systems. And so that actually took care of some of this. not all of this, but some of this. But I basically pretty much stopped teaching that in 2010. And so as part of that, I moved these topics, which I sometimes covered in that course, into this course. And I think it actually makes the course a lot better. I think it's really an important part of the course. And talking about performance database systems without really looking at the, the new and advanced stuff is kind of weak. So I think it's something that I like. Some of those ideas are old, yes. So again, we did cover some of them, like streaming. I was typically had in my advanced database systems course. And the Van Air was there at some point, and so for that one I was doing a lot of things, but that was basically a pure seminar course. It's like a whole course, like the last 3 weeks, with an independent project and so on. But basically, when I started giving that course, I pushed that into this, and so you're right. I mean, a lot of this is not very new, but some of it, even though it's published earlier, it the impact that it's having in the industry, for example, it takes a while. I mean, Hedvig was presenting something that is now a startup company. We started this work in 2003. So it's been going on for more than a decade. And so sometimes it really takes a long time to get the research ideas into industry and into really having a big impact. So it's a good question, and indeed it has changed a lot, this part. It's really new. But I think it's something that I really would not want to give the course again without it. I think it's really an integral part of the course, an important part of the course. So thank you for this question. Other questions? But keep them coming. So going to the skills, we basically, part of this is to be able to trace the operation of the major algorithms used for query processing. This is kind of the hash join, the sorting, the sort merge join, being able to look at what the optimizer does, and then trace the operations of major algorithms used for transaction management and implementation of asset systems. We did the recovery algorithm, we did locking, and so on. And so trace the operation is basically sort of to be able to simulate what the algorithms do, and being able to answer questions or understand their impact. And then the competence. So are you familiar with these knowledge, skills, and competence? These terms that are used in the learning outcomes. Yeah. So basically, sort of, sometimes knowledge is knowing, skills is being able to do, and competence is knowing when to do it. So it's a great analogy, where if you are a soldier learning how to shoot, one thing is, or learning how to treat guns, one thing is, being able to load the gun and, clean it and so on, know how it works, and what is your position and so on. Skills is being able to shoot at the target wisely, and competence being able to know when you should actually shoot the person in front of you or not. So, right, we're not dealing with that, fortunately. But so skills is basically being able to do things, and the competence, that's the choices that you have to make. And so one of the things that we do is to use metadata and queries to study the configuration content of database. Now this, you could see this as a skill, but actually it ended up as a competence because we're using this to make decisions. And then it's actually a good question. Maybe it should be in skills. Measure the performance and evaluate the need for performance tuning. You need to do tuning. That's a decision that you have to make when you're in industry. And then, what kind of performance tuning do you need to do? Do you need an index? Do you need to change server configurations? Do you need to buy memory? What is it that has to be done? And then make simple changes to the configuration of databases and database queries to improve their performance. And so that's rewriting queries, creating indexes, doing views or whatever. And so I basically try to map where each of these should have come from, and maybe this can help you a little bit when you're reviewing, where they should come from. But also, for me, it's an exercise of making sure that we taught you everything that we thought we were going to teach you, because that's important. Now, I just wrote down a few things that I think maybe, and So overall, I'm happy with the course. I got a midterm teaching evaluation said projects are sometimes underspecified. And for the big projects, I think this has to be fixed. For the assignments, I think they should be loose. But just to point out that these are learning tools. Projects are for you to learn. We have to actually evaluate. And so it's a bit of a pain in the neck because it would be nice if you could just learn from them. Now, the teaching evaluation is going on. Please take part. Tell us what can be improved, what you're happy with, what you're not happy with, so that we can keep the things that are good and fix the things that are need fixing. It's open today and tomorrow, and just it would be very nice to get your feedback on this. Yeah. Yes. Yeah. Are there particular projects that you found hard to deal with or so on? Just tell us. It's really something that is useful, and I don't care too much about the scores, but I care about the comments. I really go through the comments very carefully every time, and if they tell me something, then that's something that I can use. So please take part. One thing that I'll probably do is either make returning project 3 mandatory or make passing projects overall mandatory, because it's project 3 is kind of the key. Like I said, it's the keystone project of the course. It's really why we're here, is to learn to do tuning. So anyway, and of course, you can just tell us also, but the teaching evaluation is the good venue. It's anonymous. You just go all out. All right. Now the important part, of course, it's the exam. The exam. So have you seen the last exam, the last final exam? It's basically going to be the same format. So we have 8 10% questions, 1 20% question. There will be 3 questions that are roughly on query processing and optimization, 2 on database tuning. Now the overlap between these 2 topics can be a little bit loose because you need to understand query processing optimization for tuning and so on. There will be 2 questions on recovery and concurrency control. There will be like a miscellaneous that covers everything. And then there will be the 20% sort of multiple choice on the new architectures, on the papers, yes. And it's similar. I mean, there's an overlap between the paper list, I think, for last time and this time, but it's not. I mean, there are new papers also. So you can go this and look at the format, and then now it's just open for questions. That was what I want to say. And if you have, I mean, you can ask about particular examples, you can ask about whatever you want. Life, the universe, and everything. But you know the answer to that, so it's okay. All clear? Yeah. Right. Yeah. Right. Yeah, but I would say the midterm exam is shorter, so it can go into a little more depth, I would say. I mean, like I said, the old exam is a good way to look, and so if you find the difference between the midterm and the final exam, there will probably be something of a similar difference. But no, I would say it's kind of same, right? 5 questions, half the time. Yeah, my goal is, I mean, if you know the stuff, you should not have any trouble with timing. Now, if you don't know the stuff, then I have no all bets are off. But the goal is not to get you with the time, and the goal is to get your knowledge. If you have the knowledge, then you can knowledge, skills, and competence. Then you can get it out. Have I written the exam? Yes. You want to know what's on it? You want to know what's on it? All right. There's going to be a question about hash joins, I think. No, actually, I'm blessed with a leaky memory. So there's going to be a question about index selection, for example. You knew that, right? It's going to be a question about recovery. Yay! No, I mean, right. Hopefully, the exam will reflect the learning outcomes and the teaching. That's the hope. And yeah, there's always something new. I mean, so the format might be different from something, but the format of the exam overall should be no surprise. Like I said, you can just look at the old one and it's the same space for each part and so on. I've asked them to print it on both sides because most of the questions have 2 pages, and so you can look at them on either side of the page. Opnu. And then, well, okay. There's always Piazza to ask. I'll try to monitor it over the weekend. So if you have specific questions, you can, I'll try to answer that as soon as I can. And then, of course, you can help each other also. So if you're working on, somebody posts something, then you can explain it, then go ahead. Right? Okay. Then you're off quickly. You can go start learning or finish the last project of some other course. But thank you for the course and good luck with your preparation.